Ahoy there, my algebra folk. Sorry I cannot be with you today, but I hope you find this lesson informative. Alright, so today we're going to talk a little bit more about domain and range, but not with discrete, with continuous. Alright, so remember continuous means that we can draw the graph without picking up our pencil, and discrete means dots. Alright, so now if we're looking at domain of a continuous graph, what we are looking for is our x values. So our x values go from left to right. Okay, so it's what can our x equal from left to right? Now this is going to be not specific numbers, but remember we have to include all those numbers in between. All right? And for range, we're going to look at when we move our pencil from the top to the bottom. Because we're going to see what can y equal and every value in between. And it's a continuous line because we have to include all those decimals and fractions of decimals. Yippee! Right. Any questions so far? All right, awesome. All right, so let's scroll down a little bit. Oopsie, that's a pencil. So let's look at number one. On number one, we're going to look for domain first. Now, we are going to write these as inequalities because it's going to be a bunch of different numbers that work, not just individual numbers like we said before. So when I look at domain, I start at the left. Now, this one keeps going on and on and on, even off the screen to infinity and beyond. And I just realized now that I forgot to put my camera on. I'm sorry. So we're going to start at negative infinity, and as we go to the right, I have a value for x forever in both directions. There's always x's. It never stops going to the right. It never stops going to the left. So this one, my domain, is all real numbers. So we put in that r here. That's all real. Any number can be, x can be any number. Now let's talk about our range, or y. So we're going to start at the top, which again, that goes on forever. I'm going to keep moving down. Now, as I move down, I have no values of y past that point. It stops there. So for this one, my range, I start at -2 for my y, and then I go up, right? I can't go below -2. So my range is y has to be greater than or equal to -2, because I can't go below it. Don't worry, we do more of this. This is more of a pre-calc and algebra 2 thing. So this is an intro. So we're just going to do our best right now and take a look at it. Now let's take a look at number 2 and our domain. So I'm going to start at the left. There's no values of x over here. Starting here, I have a value for x. Now it looks like it's -1, 2, 3. And then I have a value for x all the way until +3. So that tells me x has to be in between -3 and 3. So my x values are all greater than or equal to -3 and less than or equal to 3. Now, this is where domains and ranges are actually a lot easier to deal with in interval notation. That's probably one of the reasons why we push it more in later mathematics. Now let's look at my range. So I'm going to start at the top. There's no values up here. Starting at here at 3, I do have a value. It goes all the way down to -3, and then there's nothing below it. So my range for y is going to be in between -3 and 3, or equal to. The or equal to is important on these because it can equal those. That's all I want to do with domain and range on this page because that's an intro. It's not going to be on quizzes. I just want to show that to you. Some exposure for you. All right, now we're going to skip ahead a few pages and look at functions. What is a function? What's not a function? Do we have any functions left? I'm going to put the fun back into function, spend my time number crunching. So what is a function? Oh, let's try this. Oh yeah, you can definitely see that. All right, good try, Mr. Twilliger. All right, what is a function? So before, everything we've done so far is a relation, but a function is a special relation. It's a special relation where every input and now what do we usually input in? It's going to be our x. We're going to plug something in for x. So every input has exactly one output. Or a y. You know, like y equals mx plus b. So when we plug in an x, we can only get one answer for y. So for example, if I were to give you the 0.06, 5, -2, 7, 9. Those are my 3 points of my function, possibly a function. Now, 0 goes to 6, 5 goes to -2, and 7 goes to 9. Every y has, or every x can only go to one y, so that is a function. What wouldn't a function be would be something like -4, 1, -1, 6, -1, 2. This is not a function because here I have -1 going to 6 and -1 going to 2. And that's not a function. I need one output for every x, one y for every x. Let's look at some more examples, and that'll help us out actually. What is a function? What isn't a function? All right. So when we look at number 1, what I'm doing is I'm looking at my x's. If the same x happens more than once, I need to check and make sure they're going to the same number. So I have 5, a 3, a 2, a 0, and a -1. Now, you can have multiple of the same y's, and that's okay. But you can have the same x's going to different y's. So when I look at this, all my x's are different. So right away, I can tell you, yeah, that's a function. Let's look at 2. I'm going to look at my x's. -2, 0, 2, 3, 2. Uh-oh. I have 2 2's. And one goes to -4, and one goes to 4. So that's a no. I can't have multiple x's, multiple same x's going to different y's. Let's look at 3. -4, -3, -2, 1, -3. Uh-oh. I have 2 -3's. And they go to different y values. That's a no. When I look at 4, I'm going to look at my x's. 1, 2, 3, 4, 5. They're all different. I'm good to go. That's a function. Let's go. Any questions? Ask someone else. I'm just kidding. You can ask me or whoever's in the room. I'm sure they can help you. Let's look at these and determine if they're a function. So we look at 5. Again, I'm going to look at my x's and see if there's any that are the same number. 3, -1, 0, 2. Oh, I've got 2 3's. That means it's not a function. They go to different y's. When I look at 6, I'm going to look at my x's. -4, -2, 1, 2, 5. They're all different numbers. That's a yeah. That's a yepers. All right. When you look at 7, they're all different numbers. 8, I have a 1, a 4, a -7, a 4, a -1. Gee golly, I have 2 4s. So is that a function? No. Okay. So look at your x's and make sure 1x to 1y. Now let's take a look at this one. But Mr. Twilliger, what do I do when I have pictures like this? Well, we're going to do the same thing. We're going to make sure every x only has one arrow from it, because that means that -3 can only go to 0. So that works. -1 only goes to 4. That's good. 2 only goes to 7. That's good. 4 can only go to 4. It's okay that 4 and -1 both go to 4. But I can't have this 4 go to multiple numbers. So that's a yes. Let's take a look at 12. So I have -4 going to 4. Good. But here I have -1 going to 2 different numbers. So that's not a function. -1 can only have one path to go to if I plug it in. So that's a no. Whereas 13, each one only has one path. So that's a yes. Okay. One more thing to talk about, y'all. The vertical line test. And honestly, this is the money. This is amazing. This will change your life. Probably not, but it might. So if you are given a picture of a graph, you can tell if it's a function just by looking at it to see if it passes the vertical line test. The vertical line test states that if a vertical line, so up and down, that's a line, that's a line. If a vertical line crosses a graph more than once, that's an E, then it is not a vertical line. Now, a function. All right. So for example, if I were to draw this graph right here, x, y axis, if I draw a vertical line anywhere, it only crosses it once. Hence is a function. But now if I draw this graph, a vertical line crosses it more than once, so it's not a function. It's that easy. No math required. You can just look at it. All right, let's try it. Let's do some examples. So in 14, if I draw a vertical line through my points as good as I can. Oh my gosh, that's terrible. But if I draw these vertical lines, I hit the graph more than once right there. Because I hit the graph more than once, it is not a function. Not a function. Now in 15, if I draw a vertical line through all these points, it only hits one point. So that is a function. On 16, if I draw vertical lines anywhere on this graph, I never hit it more than once. So that is a function. On 17, if I draw vertical lines in here, I hit it more than once. Not a function. On 18, if I draw a vertical line through this, I hit the function more than once. So not a function, On 19, my vertical lines only hit it once. So it is a function. 20, it is a vertical line. So no. It hits it infinitely many times. And 21, my vertical lines only hit it once. So it's a yes. All right, guys. Do your packet. Ask questions when needed. I'll see you tomorrow, hopefully.